Hey everyone, Ken and Prophet here. Welcome back to another Blender tutorial. In this tutorial, we're going to make procedural cobblestone paths by using geometry nodes. So you'll be able to just draw a curve and then have a path be populated. We're not going to use any scatter. It's going to be converting it to geo. And then I'll show you how to set up your own tool so that you can tweak all the parameters and settings to have a fully customizable procedural path. So let's jump into Blender and make some cobblestone. Inside a new Blender scene, I'm going to press A to select everything and X to delete. I'm going to press Shift A and drop in a curve, and we'll use a Bezier curve. And I'm just going to scale this up somewhere about there. Might move these handles around, just normal S and R, nice smooth curve like that. And with that selected, we'll go into geometry nodes and create a new geometry nodes network. So the curve is our geo nodes input. And that's going to be our whole network right here. And we want to convert this to a mesh. So I'm going to press Shift A and drop in a grid. And if we Control Shift click, we can view that grid, simple square. We want to map that to our curve. And the way we do that is with a curve to mesh node, drop that in on our curve. And we need a profile curve shape. And we have a mesh here, but we need to take the mesh and do mesh to curve. So hook those up and feed this shape into the curve to mesh. Now we have a nice, cool tunnel. Sort of looks like a Windows 98 screensaver. So thanks for watching, everyone. I hope you enjoy. Just kidding. We can adjust this grid shape by taking down the number of vertices along the Y. So we actually don't need 3 layers. We just need 1. And that makes a nice flat grid shape. And then the vertices on the X, we really just need 2 as well. And we can look at wireframe to see what that's doing. You probably want to adjust your curve to where you get nice even polygons. And then if you want a way to adjust the topology of this, the density, while also adjusting the width, we can set up a pretty simple math function here. So I'm going to press Shift A and use a couple of math nodes. So I'll take this math node, set it to add, give it a value of 1, and feed that into the scale X right there. And then Shift D, duplicate that. This time set this to multiply and hook up the first value like so, and take this into the vertices X. Okay, and so now when you slide this top value out on the 1, it multiplies by a value of 1 so that you get kind of a grid shape no matter how big you stretch this. So just to give you an idea, if you don't multiply it and you unhook that, then you just have these faces being stretched out however wide you want to make your cobblestone here. But if you hook that up, then you get a nice even topology. So a couple different ways you could have done that, but that works. And then now what you can do with this value is feed it into a group input node, and we can press in, and I'll just rename this width. So now we have a width slider over here, and it dynamically adjusts the topology of our path. Now there is a little bunching issue going on here, especially if we make the path wider. You can see the issue right there. And we can take care of that with a simple resample node on our curve. So what I'm going to do is drop in a resample curve node right here, and I like to set this to length. That increases the density a bunch, but if you take this value up to a 1, then we get the nice even pattern back, and it takes care of that bunching. So this is without it, and this is with it. It just helps clean up your curve shape a bit. Now, I'm not going to actually use the spreadsheet in this tutorial, so I'm going to just split my windows, give us some more space up here with our geometry nodes viewer. All right, and there we go. So we've set up a sort of a dynamic path here, and you can extrude the curve, and you get, you know, more paths. So you could use a similar setup to do all kinds of stuff. It doesn't have to be a cobblestone pathway. There's a pretty basic setup for kind of a procedural road. All right, so how do we convert this to cobblestones? Well, first of all, we need to get a little bit more geometry in there. So let's subdivide this mesh. And this is actually going to be used for kind of the cobblestone scale density. So this level input will become important later on. But if we go back to wireframe, you can see what we've done. We've just sort of given ourselves more topology here to work with. So I'll leave that on a level of 1. Now what we can do is split the edges of these polygons right here. And you shouldn't see any change when you do that. But if you drop in a scale elements node after that split edges, now when you take down the scale of this, you can see we've scaled a bunch of the polygons right here. So now this subdivide mesh level kind of becomes the generic block size of all the cobblestones right here. So we can feed this value into a group input. Then we'll just kind of do this as we go to build out our tool over here. And we'll call this scale. Even though we're subdividing, it still gives us sort of the scale value that we want for our setup here. Now, you could just subdivide these with the subdivision surface node. That could work, but we want to get some random shapes and different looks to this. And the way to do that is with a couple different ways. First of all, we could drop in a triangulate node prior to the split edges node. So I'm kind of working backwards, but I just wanted to sort of show you where we're going and then fill in the gaps in between here. So after our subdivide mesh node and before the split edges node, we're going to drop in this triangulate node. So it triangulates the polygons and we get sort of an interesting look there. So you might think, okay, we're getting somewhere a little bit closer to what we want. Once we've triangulated those, if we feed that into a dual mesh node, then we really get some magic here. We get something that looks a lot more cobblestone-y. This node is really something. It takes this input, so I'm viewing the triangulated mesh. We had this, triangulated it, and then it does sort of a on-the-fly remesh and creates this sort of Voronoi pattern, like so. And then we split the edges, scaled the elements, and then subdivided them. And now we have something that looks like stones. So pretty neat. Now obviously we want to add some extruding to these stones. And we can do that with an extrude mesh node. The nodes in Blender are just getting really, really convenient. You want to make sure you do this before the subdivision surface node. So now these are all being extruded, but we want to adjust the randomness of the offset. We don't want them all to be the same thickness. And we can do that with a random value node. So I'll just drag out that value and it can stay afloat. And this can just be whatever you want it to be. So if we set this to, let's go say 0.2 and 0.6, something like that, get a nice random look, maybe not so high, maybe more like 0.4. And then of course you have a random seed value here, make them dance. All right, so we're getting there. Now we also want to randomize the scale of all of these. So the same thing, I'll just Shift D, duplicate that random value node, feed that into the scale. But obviously we want to adjust these a lot more. So I'll go 0.8 and then about a 1.3. And it's up to you if you want them kind of overlapping, colliding with each other. I actually think that looks kind of cool. Whenever you get that, totally up to you. And then once again, you have a random seed value here as well. Now another way we can randomize the look of this is by randomizing what part of our mesh is triangulated. So here, back here on the subdivision surface, if I go to wireframe, you can see this is all just even squares and then triangulated the whole thing. And then that was fed into the dual mesh. Well, if we only triangulate some of it based on a random value node, then we can have more control over the randomness. So let's take this into another random value node. Now by default, this value needs to be a Boolean because of the selection probability. And that gives us this slider right here, what stays a triangle, or I'm sorry, what stays a square and what is converted to a triangle based on this probability slider. And then what you get with that is when you go to this dual mesh node, the sort of honeycomb Voronoi pattern we get is adjusted accordingly. And you have some things keeping their triangle pattern, some things get turned into a messy n-gon, some nice octagon. So it just further breaks up that pattern, gives us a little more noise to work with, so that by the time we get to our subdivision surface here at the end, which I'm going to add one level right there, now you can see we get even more randomness here. So if you slide around this probability, 0 is just a nice even grid pattern. All the way up, everything's triangulated. So somewhere in the middle, you get kind of the best of both worlds, and you can of course adjust that seed value as well. And now remember, we have our scale here. So if I click this up to 2, then we start to get more of a cobblestone look. But of course, that changes everything about the scale that we set. So you probably want to take that down maybe adjust the overall scale. And now we're getting something that looks a lot more like cobblestone. And remember, it's procedural and dynamic, so you can rotate this curve around and everything should follow. Now, one thing I do like to do is this on this dual mesh node. Remember, when it's converted to this point, if we do keep boundaries, it adds this nice little layer around the edges. And that's kind of a stylistic taste thing, but it looks kind of cool if you want sort of a nice even road. You know, I can see why you might want that. It looks pretty cool when you do the keep boundaries node. Looks a little more like a nice neat path. Something you may also want to do on the subdivision surface node, we have this edge crease option. If you slide that up, then you get to sharpen the edges of all these rocks, and you get a totally different look there as well. So obviously all the way up, you're gonna have just rigid, sharp polygons. You probably don't want that, but somewhere in the middle, maybe around like 0.3, 0.4, you can get a pretty cool look. And that's before adding any noise or anything. We're already getting a pretty sweet looking cobblestone path. Now let's add some noise. So after my subdivision surface node, what I'm going to do before we add the noise, let's inspect our topology here. I'm going to go ahead and add in another triangulate node after this subdivision surface. And we can see the before and after of that. This is just to kind of fill in those gaps, make everything be a little bit more even. And now after that, I'm going to add a set position node. This is going to be for the noise. And I'll do a Voronoi texture because you guys know I like that. And I'm going to set it to distance to edge, take the distance into the offset of that set position. Okay, and it's trying to displace in the X, Y, and Z, and we want to displace based on the normal of our object. So I'm going to do a vector math node and drop that in here. Set this to multiply, and then I'll multiply by the normal of our pathway and feed that into the vector. So now we get displacement along the normal, which is exactly what we want. I'll Shift D duplicate that multiply node, and now we can kind of control how much displacement we have here. So there you go, we're kind of breaking up the look, and we can increase the detail, which will allow us to break up the look even more. We don't have a ton of geometry here, so that's why everything's looking pretty faceted. But once you start cranking up the subdivisions, you can start to have that detail come through. Just remember, the more you crank up the subdivisions, obviously the more expensive your viewport render gets. So just be mindful of that. But somewhere around there, that's looking like rock, like stone, pretty cool. And now what we can do after that noise is just drop in a set shade smooth node right here. And that shade smooth takes away a lot of those faceted edges. Now you could do a lot more noise displacement. You could do another noise texture, but I prefer for a lot of that look to come from the shader, which is what we're going to set up next. So let's go ahead and make a new material for this. We'll create a new material and we can name this cobblestone. And I'll do a set material node after everything and drop that in here. And then just select that cobblestone material that we created. And now that's applied to our whole object. Now if we go into the shader editor, we can actually work on our materials. So if I change this to blue, it should change because we set that in the geometry nodes editor. Now I'm going to go to rendered mode and I'm going to use cycles for this. And I'll just set up a simple sky texture and let's do a simple sun as well. All right, so I have just a simple lighting setup, just a sun and a simple sky texture in there. You'll want to spend a lot more time on lighting of your scene, but we're just trying to set up a nice rock shader here. And this will be very simple, but I want to mostly illustrate how you can isolate these individual rocks to give a nice, interesting material variation. So I'm going to press Shift A and we're just going to mix some noise textures together. So if I Control Shift click view the noise texture, you can see this is being applied over this object as a whole. So let's take this vector input into a texture coordinate node. And instead of generated, let's do object. Okay, so now we can adjust the noise pattern in a bit more even way, crank up the detail a good bit, as well as the roughness. And I'm going to kind of clamp this together with a color ramp node. Just squeeze these values together, get a nice black and white value like that. All right, and then I'm going to feed that into a mixed color node. And we'll just mix together grayish blue color and a darker grayish blue color and feed that in as the factor of our mix. So there we go. Now we have a factor of that. I'm going to grab everything, or just this noise texture. Control-Shift-D, duplicate to maintain the connection. And this time let's just adjust the scale a bit. And we're going to give kind of a different hue of stone here. So now we have that noise pattern and that noise pattern. Okay, and you can adjust this accordingly. And now we want to mix the two of these together. So Shift-D, duplicate this mix node. Just feed them in like so. My materials are not very sophisticated, guys. It's just mixing noise textures and color. Let's mix these based on a Voronoi. How about that? We'll drop in a Voronoi texture. And same thing, hook that up to the object. We can view the Voronoi. And I always like distance to edge. Let's crank up the detail and the roughness so that those lines aren't as prominent. And let's do a color ramp node. Squeeze these values together. Gives a nice pattern. And we'll take that as the factor mix of the two colors we kind of mixed together already. You might adjust the scale of this as well. But really what you're getting is, it's hard to show because we're just viewing the color, but you want a good variation of noise mixture upon noise mixture, so that anytime you're layering, you're viewing a color underneath a color, it's revealing something else. All right, and you want enough saturation value in there that we can randomize that later on. Now, another really cool thing we can do is drop in an ambient occlusion node. So I'm going to drop that in, and if we view the color of this, you can see we see sort of the underneath shadow of all of these stones. Let's cut the distance in half maybe, and we can crank up the samples as well. So you could use this for a lot of different things. You could use the inverse of it for shadows or highlights. In this case, I think I want to use this for a nice darkened shadow to sort of punch up the cobblestone look of our material here. So I'm going to duplicate this mixed color node and feed everything we've done so far into the top. Control Shift click view that, and then I'm going to take a nice darkened color down like that, and I'm going to set this to multiply, and I'll take this color output of our ambient occlusion and I'll just drag that into the factor of this multiply node. All right, that's kind of the exact opposite of what I want, but you can see what I'm going for here, the way you can use this for a highlight or a shadow. And I'm going to reverse and punch this up with a color ramp node. So we can just switch this around like so. And now you can hopefully see what I'm getting at here, how we're able to really punch up the individual look of all of these rocks by using this ambient occlusion node. Now, I don't want it to be too extreme, but just enough where it really adds individual depth to each one of these stones. So once I'm happy with kind of the level that I've got here, I might increase this overall distance. And then this white value, I'll just take it down a bit so that's not as extreme, somewhere right around there. I have a rock tutorial that goes over using this method to add like stylized highlights to your rocks. So you could totally check that out and do the same thing, add a highlight along all of these stones. Okay, now we also want to randomize the hue, saturation, and value of these individual stones. So you might think, well, how are we going to do that? It's all one mesh from our geometry nodes network. It's a procedural setup. Well, there's this really awesome node called a geometry node, not to be confused with geometry nodes. But here we have a geometry node, and if we Control Shift click and view through this, you get all kinds of really fun, interesting data from this node. In particular, there is this random per island node. And look at that. We have a black and white mask of every stone that we created in our GeoNode setup. So lucky for us, we can use that to randomize heck, anything. You could, whatever color, anything in the material you want to do, it was really hard for me to kind of narrow down exactly what to do for this tutorial, but just to give you an idea, if we take in a hue saturation value node, take our color output into the color of that and feed that up. Let me just view the hue saturation value node right there. If we randomize any of these items on a per island basis, feed that into the value, for example. Now look at that, we get different value of rocks. You could take it into the hue and get different hue of rocks and saturation. You could randomize all of these things. You could have it split between two totally different colors. So if you had like, you know, if you wanted to do something like this, for example, this is just for funsies. I have a color ramp node. Let's set this to constant. Let's just create a bunch of colors here. So we'll do red, and we'll do blue, and we'll do green. Okay, take the random output into this color ramp node, and now view that, and now we have red, green, blue. And then of course, you can factor out which ones you want to see of which by sliding this around. So a really cool way of randomizing right here. So that's just an example of what you can do with that random per island node. It just gives you this really cool mask kind of built in where you can generate randomness per stone. And now if you say, well, I don't actually want that values to be that dark or that light, you could take down how much randomness you see by utilizing this hue saturation value node factor slider, which is just really awesome. Really simple way of randomizing a material that's applied to a geometry nodes. Our color input is all done, and we can view our principled BSDF and see what that's looking like. And now with everything else applied, it's looking pretty cool, but we want to add a little bit of roughness value breakup and a little bit of bump. So let's create a roughness map based on everything we've done up into this point. We can do that with just a simple color ramp node. Again, a lot of different ways you could do this. I'm just trying to keep things simple for simplicity's sake. I'm actually going to reverse these values, I think is what I want to do. And then I'll feed that into the roughness and view that just to get some roughness breakup. This is kind of hard to illustrate in a tutorial because there's usually a lot of back and forth with rendering as far as a roughness map goes. But hopefully you get the idea, a little bit of breakup there. Now let's add a little bit of bump. For bump, I'm just going to grab a generic noise texture and view that. And I'll take this into a texture coordinate node and we'll use the object. And let's go pretty high on this. I'll feed that into a color ramp node so that I can really adjust how much noise we're seeing here. And then let's feed this into a bump node. We'll take the color output into the height of the bump node and the bump into the normal of our principled BSDF. And now hook all this up and you should see some bump coming through on our rocks. Again, this isn't a very sophisticated bump node, but if we take this distance to 0.5 and I'll take the strength down to 0.5 as well, we have a nice randomized hue saturation value cobblestone road. You might want to play with things like the roughness map, get some shininess depending on if you want wet looking rocks or hard sharp looking rocks. This material can be tweaked and adjusted to that. And obviously there's a lot more interesting things you could apply. Something I like to do is maybe like a mixed color node over top of everything. And you could get like some nice green in there, something like this. And then just use a noise texture, but don't do anything with the vector factor of it. Just make a really big kind of noise texture. So scale of 3, and then drop in a color ramp node to kind of further decide. My viewport is slowing down a little bit, but you get what I mean. You can kind of add a sort of hint of mossy color over top of everything, and then just sort of darken this. Maybe set the blend mode to screen so that you don't destroy any of the detail that you've gotten from your material up into that point. And then there you've added a little bit more variation as well. And you can take away the contrast of this, slide down that value. Just something subtle, a little bit of green, maybe it looks like green mossy growth on some of the rocks. Then the only steps would be to hook up whatever you want control over in the right-hand side into your group input. So you would probably for sure want control over the subdivision surface. So I'll take that into a group input. That way, if I want to quickly adjust my path, I can take it down a level and now it's all low poly I can make quick adjustments. You probably also want to hook up like the scale randomness or the extrude randomness, anything like that to give you control in your final tool. You get the idea. That's how to create a procedural cobblestone path inside of geometry nodes. So you can extrude and rotate, and then you can adjust the width. And then it'll all stay procedural, and you can bump up the level, the subdivision level as well. And then when you view that in your rendered viewport, it'll get all the cool material applied that we set. And then the only other steps would of course be to put it in a scene, get some proper lighting in there, and you're off to the races with a fully procedural cobblestone asset that you created inside of geometry nodes. All right, so that's it for this video. Thanks so much for watching. Shout out to all my Patreon members. If you want to download my completed cobblestone path tool, you can grab that from Patreon and check that out. You can reverse engineer it or just use it in your own Blender scenes. Thanks so much for watching, everyone. I hope you enjoyed this tutorial. Please leave a like and subscribe if you're not subscribed, and I'll see you next time in the next Blender tutorial.